EcoDesigner Start enables architectural designers to calculate and visualize the performance of the ArchiCAD building model's constructional details. This thermal bridge data can then be included in the building energy model in order to maximize building energy analysis accuracy. The results of the thermal bridge energy analyses will be associated with the thermal blocks and help to provide even more accurate energy analyses. Let's see briefly how this works. Here you can see a detail of the currently open ArchiCAD building model. This detail has been automatically generated from the central building information model. If required manual adjustments of the details are necessary, they can also be performed using ArchiCAD's editing tools. Please note that the labels, dimensions, and text do not affect the result of the thermal bridge analyses. The simulation can be started by initiating the Design, Energy Evaluation, Thermal Bridge Simulation command. This can also be initiated from the Context menu. The Thermal Bridge Simulations dialog displays various options and characteristics about the construction detail. Let's start by reviewing the properties of the external air boundary conditions. First, we have to define the external air area by clicking the preview drawing of the detail on the right side of the dialog. Please note that multiple fills can be selected and defined as external air with the help of the Shift button. The number of selected fills, as well as the color of the external air, are visible on the left side of the dialog. We can also define the temperature of the external air, as well as the external heat transfer coefficient. Let's click the Next button to proceed and review the characteristics of the internal air boundary conditions. Again, using the mouse and the Shift key, multiple fills can be defined as the internal area on the preview drawing. The internal air temperature, as well as the internal heat transfer coefficient, can also be provided or edited. Let's proceed by clicking the Next button and have a quick look at the settings of the soil boundary conditions. Defining a soil area is necessary to specify which fill of the building detail should be treated as soil throughout the thermal bridge analyses. Here we can define the soil area, if any, using the same method as before. The type of the soil can also be altered. We can fine-tune the type of the soil at the Environment Settings dialog. Various predefined soil types can be selected from the pop-up list. The thermal conductivity, density, and heat capacity of the soil can also be provided. In this example, we'll analyze a roof detail, so we will not define any soil area at this time. Let's proceed and assign thermal properties to the fills of the investigated building detail. The list on the left displays all the fills of the detail. Click any of the fills on the list on the left, and the fill will be highlighted in the detail drawing on the right of the dialog. We can zoom in and then pan in the detail drawing to have a clear view of the fills and their relations. We can also click any of the fills in the detail drawing on the right, and the corresponding fill entry on the left will be selected automatically. The thermal properties of the cut fills can be edited manually. Simply click the button next to the fill entry in the list to open the Thermal Property Assignment dialog. Here we can enter thermal conductivity, density, and heat capacity values manually. Certainly, all these values can be filled out automatically using the built-in catalog of EcoDesigner Star. The Material Catalog contains an extensive set of materials and their thermal properties. All we need to do is select one of the materials with predefined settings. Let's return to the Thermal Bridge Simulation dialog without performing any changes to the thermal properties of the cut fills. Let's proceed and have a closer look at the simulation options. It is possible to set the grid size for the thermal bridge simulation algorithm. This enables the limitation of the thermal bridge calculation's detailed level in order to decrease simulation runtime. Furthermore, the Show Grid Contours on Preview option enables the visualization of this setting. Please note, choosing more detailed provides a more accurate result, but may take a longer time to calculate. Finally, let's proceed and start the simulation by clicking the Start Simulation button. The simulation results will be displayed in seconds. EcoDesigner Star displays the temperature and the energy flow diagrams for the selected building detail. Simply click the temperature or energy flow buttons on the left side of the dialog to display the corresponding color-coded diagrams on the right side. The values corresponding to the colors are also displayed. The psi value is also calculated as part of the simulation results. The other three values below the psi value give detailed information regarding the thermal bridge simulation process itself. Let's display the temperature results and zoom into the detail drawing. Please note that as we move the mouse over the detail, the numeric temperature value is also displayed. Please note that the internal surface temperature of the roof structure and that of the glazed surface is also calculated and can be displayed with the help of the mouse. Let's switch to the energy flow diagram. This diagram greatly helps to visually identify thermal bridges in the construction details of the building. Please note that both diagrams can be placed as drawings upon request. All we need to do is click the Place as Drawing button below the colored diagrams, and it will be placed upon the original detail drawing in the design project. The diagram can then be repositioned and further fine-tuned if necessary. The results of the thermal bridge simulations can be associated with the thermal blocks. Let's return to the floor plan view and then activate the Design Energy Evaluation Energy Model Review command to open the Energy Model Review dialog and display its Structures page. Let's click the Management Thermal block by clicking its name in the list. Now let's display the context menu by right-clicking this thermal block, and then activate the Add Thermal Bridge menu item. The very same command is also available by clicking the Add Thermal Bridge to Selected Thermal Block icon at the lower right corner of the Structures list. The thermal bridge selection diagram is displayed. Here we can select the previously calculated thermal bridge to the selected thermal zone. The newly added thermal bridge will be instantly displayed in the list, and if necessary, multiple thermal bridges can also be associated with the same thermal block. The corresponding calculated psi value is displayed at the Structure's Property page. Here we can also define the length of the thermal bridge in millimeters. Let's enter 10,000 millimeters for this thermal bridge. The energy simulation can also be accessed from this page by clicking the Open Thermal Bridge button. It is possible to override the input values for the thermal bridge simulation, but in this case, the simulation itself must be repeated to newly calculate the resultant psi value.